Okay, in this example, we want to find the rate of change of the potential at the given point. And then potential is actually the function v, right? And then the direction vector is 1, 1, negative 1. Okay, so the rate of change of the function is actually the directional derivative. So that what I want to do here is, our potential is v, and then our vector is 1, 1, negative 1. I think it is not a good idea to use v twice, but it is the big V, and then it is the small v, right? Okay, so here what you want to do find is dv, directional derivative, with respect to the small v direction at the given point 3, 4, 5. Okay, so that the first one, we need to find the gradient vector, because this one should be the same as the gradient vector of v at the point 3, 4, 5, dot product with the given unit vector in the direction. Okay, so that what you need to do is you first find the gradient vector, and gradient vector is actually vx, vy, and vz. And using the given function here, you can find the gradient vector, and it should be 10x minus 3y plus yz, and then vy is negative 3x and then xz, and vz is plus xy. Okay, and if you plug in the given point 3, 4, 5, then you get 30 minus 12 plus 20, and then negative 9 plus 12, and then xy is 12, so that you should have 38, and then 3, and then 12, right? And let's first find the unit vector in the given direction, and given vector was 1, 1, negative 1, and then if you take a norm, it should be 1 plus 1 plus 1, so that you have square root of 1, 1, negative 1. So that if you plug in what you got here, 3, 8, 3, and 12, so that the product with the unit vector, this direction, then you will get square root of 3, 8 plus 3 minus 12. So let me see, it should be 29, I guess. Yes, it should be, yes, 29. So that the answer would be this one for the problem 1. And then, here, the second problem is in which direction does V change most rapidly at P? Actually, you know that the most rapidly changed direction should be gradient here, V direction, right? And since we found here the gradient V, so that we can say, yes, this one, the answer should be the direction 3, 8, 3, 12, because it is the gradient vector 3, 4, 5. Okay, and then what is the maximum rate of the change at P? It is actually the norm of the gradient vector, right? So we can say it is the square root of 38 squared plus 3 squared plus 12 squared. I don't want to calculate it, but yes, if you simplify, you just calculate this number, then it should be the answer.